So welcome to my session. In this session, we're gonna talk about the cardiac muscle cells of contractile cells. So in the first place, we explain the sinoatrial node pacemaker and the space and the sinoatrial and atrioventricular nodes are connected by internodal pathways, and then after that atrioventricular connects the atrioventricular bundle of his, and the bundle branches goes to into the interventricular septum and into the Purkinje fibers, and Purkinje fibers into the papillary muscles to the tricuspid and bicuspid valves, and to the myocardium of the heart. So in this section, I'm going to say about the contractile muscles. So the contractile muscles, which are fast non-Baker action potential, which have stable membrane potential, which depolarization occurs on conductile AP open fast sodium channels, massive sodium influx and depolarization. So this conductile action potential, open fast sodium channels, massive in Na influx, these are the massive Na sodium influx and open fast sodium channels help in the depolarization of the non-pacemaker contractile muscle. So it have stable membrane potential, does not change their membrane potential, it is stable. So the plate show the fast sodium channel closes, so voltage gated calcium channels to open. So the sodium channels closes to open the voltage gated calcium channels. So cancel calcium influx and adding with calcium release from sacroplasmic reticulum cause the muscle contraction, increase of muscle contraction. So the calcium influx and the calcium release from sacroplasmic reticulum causes the muscle contraction in contractile muscles, contractile cardiac muscles. So in the platio, the NH sodium channels closes, and the contractile the muscle contraction occurs due to the calcium influx and calcium release from sacroplasmic reticulum, and the platio is balanced by calcium influx and potassium efflux. And next is repolarization. So depolarization occurs in the conductile from the conductile action potential generated from the bundle of his and the Purkinje fibers and the SA node and AV node. So when this conductile action potential occurs, this depolarization occur when it opens sodium channels. So the sodium channels helps in massive sodium influx, so sodium influx increase by opening of sodium channels, leaking of sodium ions, so causes sodium influx, increase in sodium influx. So it causes depolarization of that muscles. Depolarization of muscle occurs, and the platio means the area will have channel. The sodium channels get closed after leakage, and the voltage gated calcium ions channels opens, and this cause calcium influx and calcium release from sacroplasmic reticulum. This causes the calcium release and influx and calcium release from the sacroplasmic reticulum, and this causes the muscle contraction. Next is plagio is balanced by calcium influx and potassium efflux. So this plagio means the balance of the muscle contraction is balanced by calcium influx and potassium efflux. Next is repolarization. So repolarization influxing calcium channels close, but the effluxing potassium channels remains open. Influxing calcium channels close, but the effluxing potassium channels remain open. The calcium channels get closed by effluxing, but the potassium effluxing channels remains open. This causes repolarization. So the calcium channels was opened by the first Na channels close, and this causes calcium channels to open, and the calcium channels open, and it opens the potassium efflux. When the influxing calcium channels close, the effluxing potassium ions channels remains open. So this causes repolarization though. So the opening of potassium channels help in the potassium channels help in the repolarization. So this excessive sodium and potassium deficit, sodium ion and potassium ion deficit is dealt with by sodium potassium ATPs. So if there is a deficit in this sodium and potassium ion levels, it is dealt with sodium and potassium ATPase. So excessive calcium ions from the pleasure phase is eliminated by sodium calcium exchanges. So excessive calcium from the pleasure phase is eliminated by sodium and calcium exchanges. So you can see in this image, this is membrane potential. So in the onset, the depolarization, a rapid depolarization due to opening of voltage gated fast sodium channels. So the depolarization generatively occur rapidly due to the opening of sodium channels. And after the opening of sodium channels, the depolarization rise to the 20 plus level, and then it comes down to the 10, and then to the second level of the pleasure level. In the pleasure level, maintained depolarization for a time period occurs. This is according to the 300 millisecond. So according to the half of the second, the depolarization is maintained due to the opening of voltage gated slow calcium channels and closing of potassium channels. So this depolarization is maintained by opening of calcium channels and closing of some potassium channels, and then after it goes down, the down level of repolarization. So the repolarization third phase is due to the opening of voltage gated potassium channels and closing of calcium channels. So repolarization is occurs by the opening of the efflux of potassium channels, flexing potassium channels, and the closing of calcium ion channels. So it is due to the efflux of potassium ions. Depolarization in first phase is not due to calcium, rather it is due to sodium. So the maintenance of repolarization is occurred due to the calcium ions. So this the pleasure phase, calcium ion is important, and in the efflux phase or the repolarization phase, potassium ions are essential. And the first phase, the rapid depolarization phase, the leakage of sodium ions help in the depolarization, opening of the voltage gated fast sodium channels. So the depolarization, you can see it is about 1 by 2 by 3 of the map is depolarization, and the small phase of 1 by 3 of it is repolarization. I can see at the red graph, it has a resting membrane potential. At last, it has a resting membrane potential. So this refractory period is absolute and it is relative, and contraction occurs between the depolarization to the beginning of the relative repolarization. So the absolute contraction occurs from the depolarization to the the beginning of the opening of potassium calcium. So you can understand this three phases. First phase, depolarization phase, pleasure phase, repolarization phase. So this can be also maintained if there is a sodium potassium deficit. It can be maintained by sodium. If there is a deficiency in sodium ions and potassium ions, its deficit is dealt with sodium and potassium ATPase. And the calcium excess, if there is calcium ion in the pleasure phase, it is eliminated by sodium calcium exchanges. Next is the Purkinje fibers. How Purkinje fibers help in contraction. So it is specialized myocytes with very few myofibrils. So Purkinje fibers is connected to the papillary muscles. So it is very specialized myocytes with very few myofibrils. It is non-contractile. It is non-contractile. Does not contract. So it is conductile but resembles ventricular myocytes. It has a resemblance of ventricular myocyte and is capable of spontaneous depolarization 50 beat per minute. So it does not contractile. It has a very few myofibrils and it is not contractile. It does not contract. So this conductile but resembles to ventricular muscles. It conducts the bundle of his pathways energy, and the location of this Purkinje fibers is in the interventricular walls of heart just below the endocardium. So just below the endocardium, the interventricular walls of the heart, these Purkinje fibers are seen. Or inside the just below the endocardium. Just below the endocardium means the inside of the myocardium. There is a layer endocardium, so it is below the endocardium. So the location of the Purkinje fibers is just below the endocardium. So it does not contractile, but it conductile. It resembles a ventricular. It has a resemblance of ventricular myocytes. It is a myocyte with very few myofibrils. It is not contractile, capable of spontaneous depolarization. And it helps in spontaneous depolarization. Next is atrial and ventricular myocytes. The atrial and ventricular myocytes, cells with many myofibrils, contractile protein. Atrial and ventricular myocytes are cells of the myocytes are seen inside Purkinje fibers. Next is which helps in contractile proteins. So atrial and ventricular myocytes. Atrial and ventricular myocytes. So these atrial and ventricular myocytes are cells with many myofibrils. So it are contractile proteins. These atrial and ventricular myocytes contain many myofibrils. There are the many number of myofibrils larger than the Purkinje fibers. So it is seen in atrium and ventricles. So these cells have many myofibrils and it has contractile proteins. So it produces the contraction necessary for heart function. So this contraction is produced which is necessary for the heart's proper functioning. So you can see the contractile and the conductile. From the conductile, SA node, AV node to the bundle of his to the Purkinje fibers. The contractile occurs from the conductile AV node. Depolarization of conductile action potential created. Fast non-pacemaker action potential which have stable membrane potential is depolarized. The action potential, conductile action potential inside the occurs in the AV node is transferred to the bundle branches, and this transfer of flux or the action potential opens sodium channels, opens fast sodium channels, and massive sodium influx creates depolarization. So the sodium influx create depolarization in the membrane potentials, and in the plagio the fast sodium channels close and voltage gated calcium channels to open. So the calcium influx plus the calcium release from sacroplasmic reticulum helps in contraction, causes muscle contraction. So the calcium influx and the calcium release from the sacroplasmic reticulum causes the muscle contraction. So it is very important that the how the muscle contracts. So the calcium influx and the calcium release from the sacroplasmic reticulum both have the property of creating three calciums. One that is generated during the closing of sodium ion channels in the plagio, and this causes the voltage gated calcium channels to open. This create the calcium influx CF2 plus, and a secretion of calcium release calcium release from the sacroplasmic reticulum causes the muscle contraction. So the plagio is balanced by calcium influx and potassium efflux. So plagio is balanced by calcium influx and potassium efflux. So the balance of calcium and sodium channel potassium is the all this is balanced by calcium influx and potassium efflux. So the repolarization, as you can see, it is due to the influxing calcium channels, which influxing calcium channels closes, but the effluxing calcium potassium channels remain open. So the repolarization is caused by the influxing calcium channels closing, but the effluxing potassium channels remain open. And actually, after that, the influxing calcium channels closing and the effluxing potassium channels remain open. This potassium channels causes the repolarization. It is and the muscle contraction ends here. The last stage of muscle contraction is due to the starting of the effluxing of potassium channels. So influxing of calcium ions stops, closes, and the effluxing of potassium ion help in the repolarization of the membrane potential. And at last it goes after the repolarization, it goes to the stable resting membrane potential. So this muscle always have a stable membrane potential, and this stable membrane potential is depolarized by the sodium ion channels, and the sodium ion channels are fast sodium ion channels are there. It causes sodium influx, massive sodium influx, and causes depolarization. and the depolarization in the pleisure, the sodium channels are closed. In the pleisure phase, the sodium channels are closed, and the calcium voltage gated calcium ions to open, voltage gated calcium ions to open, and this causes the calcium production of calcium influx, and plus the calcium release from the sacroplasmic reticulum. So the fast sodium channels closing voltage gated calcium ions to open, and this causes muscle contraction, and muscle contraction is caused by the release of calcium plus influx, and plus the calcium ion influx, and plus the calcium plus calcium release from the sacroplasmic reticulum. This causes C3 plus, and the C3 plus increases the muscle contraction, and this muscle contraction is stopped by the potassium efflux. So the calcium ions are, the influxing calcium ions are closed. The influxing calcium ions helped in the contraction is closed, and this contraction is due to the influxing calcium ion, and when it is closed, the due to the effluxing potassium channel release. So this excessive ions, the excessive sodium and the potassium deficit, all are dealt with sodium and potassium ATPase, and the excessive calcium from the pleisure phase is eliminated by sodium calcium exchange. So we have to say, after the effluxing, all these excessive calcium, sodium ions, calcium, potassium ions, if it is deficit, they help the, if it is deficit, the sodium potassium ATPase helps to deal with the problem, sodium and potassium ATPase. And if it is excessive, if the calcium is effective, if the calcium is excessive in the pleisure phase, the potassium and the calcium exchanges help in the elimination. So at the end, the repolarization is due to the effluxing of potassium ions, and the membrane potential goes to the stable. So we can see this SA node, which is a conductile node, atrial node. You can see it is a sinoatrial node is a pacemaker. We in the last session we said about how much the position of this correct position is the posterior wall of the right atrium near the opening of superior vena cava. Posterior wall of the right atrium of the superior vena cava. Vena cava is always superior. So according to the position of the SA node, it is superior to the vena cava and posterior wall of the right atrium. So after that, there is AV node. AV node is known atrioventricular. So this AV node creates 40 to 60 beats per minute. It is slower than SA node. So in between there is a atrial muscle. You can see there is a internodal pathway. So this internodal pathway has a atrial muscle. So SA node helps in the contraction of that atrium. That conducts to the internodal pathways to the AV node, and the AV node passes through the Purkinje fibers, the bundle of his through the Purkinje fibers, and it causes ventricular muscles to contract. Everything happens in a millisecond. Like you see the refractory period and the contraction period. Thank you.